Right, so we have this graph of x squared minus 2x plus 3, and we're asked to draw a straight line and estimate the solutions of x squared minus 3x minus 1 equals 0. Okay, so we have a quadratic here and we're given another quadratic equals 0, and yet we have to draw a straight line. How do we do that? Well, the way to do it is this. Okay, let's write this out here. So we have y equals x squared minus 2x plus 3. Okay, and write this one underneath. We have x squared minus 3x minus 1 equals 0. Okay. What you have to work out is the difference between these two. Okay. Now, the x squareds are the same. Now we've got minus 2x, so this has minus 3x. So, if we take y, that's that, and we subtract one more x, we get this. Okay. Now what about the numbers? Plus 3 to minus 1. If we subtract 4 from y, we get this. Okay? So we don't have to do anything with the x squared because that minus that, well, they're the same. Okay? So y, that thing, minus x minus 4 equals this. X squared minus 3x minus 1. Okay? So another way you can look at it is y minus, well, I'll just rewrite it, x plus 4 equals x squared minus 3x minus 1, either. Okay? Good. Now, we're looking for solutions of this thing, okay, equal to 0. So when this whole thing is 0, that's what we're interested in. So in other words, y minus x plus 4 equals 0, because that is 0. Okay? So in other words, take that over there, y equals x plus 4. Okay? And that's our straight line. So this thing equals 0, right, when y equals x plus 4. And y, the way I've written it here, y is this graph here. So when that equals x plus 4, it's where the straight line of y equals x plus 4 crosses this graph here. Okay? So we have to draw the line y equals x plus 4. And that's going to look like this. It's going to go through, when x is 0, y is 4, so it goes to that point there. It's basically the line y equals x moved up 4. So let's go for it. Okay, something like that. Y equals x plus 4. Okay. And this is 0 where these two lines cross. So the solutions to this are x equals the x value of that point there. So something like that on my hand drawing of this. And the x value of that point there. So something like there-ish, okay? So you read off, you get your ruler, place it there, okay? And read off or nothing wrong with drawing a line as well, if you want, with a ruler. I don't have a ruler, I'm drawing it by hand. You should use a ruler, okay? To work out or read off that value there on the x-axis and that value there. Okay, now I've drawn this by hand. It won't be a perfect recreation of the one on your question sheet, but if you've done this accurately on your question sheet, you should get a value of about minus 0.3 there, okay? And this one should be about 3.3, okay? So those are the values you're looking for. Now I know on mine that looks more like minus 0.7 and that looks more like 3.7, but again, I've done this by hand. The method is what's important, not really the numbers, okay? But on yours, you should get about minus 0.3 and 3.3. Excellent. Right, now the next bit. P is the point on this graph where x equals 2. Okay? Now, when x is 2, 2 squared is 4, minus 2 times 2 is 4, so that's 0 plus 3, y is 3. So if I've drawn this accurately, 2, yeah, not bad. I have drawn it reasonably. So x is 2, y is 3. So that's the point P. Okay? Right. Estimate the gradient at P. Piece of cake. To do this, get your ruler again and place it so it's tangential to this curve, y equals x squared minus 2x plus 3, at the point P. Okay? And draw a nice long straight line. So get your ruler, tangential at the point P there, and draw a straight line. And on mine, it's going to look something like, let's just go for it. Something like, just should clip it there, something like that. Okay, I just missed there, but it's meant to just clip this curve at that point there. Okay, good. Right, so first thing to do is draw the tangent of the point P. Now the gradient is rise over run. So what you have to do is choose a sensible point to take on P, somewhere down here and somewhere up here, such that you can work out from this point to this point, the rise and the run. So what I mean by sensible point is something just makes your calculations slightly easier, okay? You could just choose any point there, boom, and just read off whatever it is, 6.98 or whatever. But that's making life hard for yourself. Let's choose 7, because it's a nice round number. So we'll go with that point there. And then, so make sure put your ruler there, okay, and measure across, make sure you've got it at exactly the point 7. And then put your ruler here and go down and work out whatever that value of x is. Okay, so from 0 to 7 is going to be our rise. Okay, so that's the rise. Now the run is from that point there to that point there. Okay, so from there to there, that's the run. Okay, now again, I didn't have to choose that point. You can choose any point you want. You could choose some point here, but again, if we did choose that point, then the run would be from there, whatever value of x that is, all the way over to here. But you're making life slightly harder for yourself, because then the rise, you have to read off that value of y, and the rise is from that value to 7. If we choose the point on the x-axis, it just makes life slightly easier for you, because you know it's from exactly 0 to 7, so the rise is easy, it's 7. My point is, you've got some triangle, okay? And it's totally up to you which 2 points, that one there and this one there, you choose. Just whatever points you choose. Okay, the rise is the y value from there to there, okay? And the run is from the x value from there to there. But it's totally up to you which 2 points you choose. Okay. Whatever 2 points you choose, it doesn't affect the gradient. Because if we move this point up here somewhere, the rise will get smaller, but the run will also get smaller. So when you divide rise by run, you get the same number. Okay. So, gradient, rise over run, which is, okay, in my case, the 2 points I've chosen, it's from, the rise is, the y value goes from 0 to 7. So the rise is 7, and the run, in my case, is, I'd say that's about 4.3. So it's 4.3 minus, I'd say that's about 0.5. Okay, so that's 7 over 3.8. Stick that in your calculator, and that's the gradient. Now, again, I want to stress these are my numbers, which I've got from drawing this by hand. Yours will be different, okay, on the question paper. As I keep saying, I haven't perfectly accurately recreated the question here. So, I'm not going to bother putting that into the calculator. It doesn't matter. It's the method that matters, okay? Now, when you do it on your question sheet, apparently you should be getting a value of between 1.6 and 2.5, okay? So that's actually, that's roughly 7 over 4, which is a bit less than 2. So I might have actually got it within that range just by doing it by hand. I think I did. Yeah, that's bigger than 1.6. Good. Okay. So that's how you do it. Okay, done. So when you calculate the gradient, your value should be somewhere between these two values. Right, okay, done. So that's how you work out gradient. It's rise over run. Draw the tangent, choose the 2 sensible points, you get your triangle there, and gradient is rise over run. There we go. Thank you for watching. I hope you found this video helpful. If you did, please click the like button, and it would be a massive help if you could subscribe. It would also be amazing if you could support me on Patreon. All the papers and everything are on my website, drjem.com, and I'm also on social media. Thank you.